Hi, Ben with Novalux Stereophonic. Thank you so much for coming by the channel. Today's video is going to focus on a very cool receiver, the Sansui G-901DB. This is a gunmetal variant of a very sought-after Sansui receiver called the G-9000. If you own a G-9000 or are thinking about purchasing one, this might be a great video for you to check out just to learn a little bit more about this product. I'm going to cover basically everything you'd ever want to know about this piece. We'll start out with some historical context. I'll then take a look at how the G series was transitioned into the Sansui product line. I'll show off some unique literature that I got with the unit, and then we'll do a front, rear panel, and side panel review to show off all the connection points, what all the switches and buttons do. Then we'll open the unit up, take a look at the restoration that I completed, and then finish up with some bench testing to verify the results. So if that sounds cool, stay tuned, and we'll get started. Let's start out with some basic info about this receiver. The G-901DB is a variant of the G-9000DB. It's essentially the same exact unit electronically, but cosmetically it features a gunmetal colored faceplate and alternate vinyl wrap, rosewood instead of walnut. Many brands such as Pioneer, Kenwood, and Sansui offered multiple versions of their products for various world markets, many of which allowed for multi-region voltage switching. Models with black or gunmetal faceplates are often referred to as Euro versions due to the fact that they almost always have the ability to run on 220, 240 mains and are rarely sold directly to the US market. That descriptor, though, it's not 100% accurate, as many units were simply designated for general export and ended up being distributed all over the world, not just Europe. Many of the black or gunmetal-faced units found in the US today were originally purchased overseas by active-duty military personnel through various mail-order catalogs and physical on-base stores known as base or post exchanges, BX or PX for short. Some bases even had audio clubs that could offer very competitive pricing on quality electronics. In the case of Kenwood, they even had special faceplate variations made just for the clubs. When the owners of the equipment returned to the US, they would usually bring their stereos back with them and make the necessary adjustments for operation on 120 volt mains. For this receiver, there are 3 adjustments that need to be made. An adjustment to the voltage switch to set up the primary wiring of the power transformer for 120 volts. The mains fuse needs to get adjusted, and the FM de-emphasis needs to get changed. I will outline these in more detail when we take a look inside of the unit, but for now I do want to talk a little bit about FM de-emphasis as it relates to another variation parameter. When the G-9000 was launched, it featured a control called Dolby FM de-emphasis. This control simply applied the proper de-emphasis to the received FM signal to get it ready to be fed into an external Dolby FM decoder. The G-9000DB added onboard Dolby FM decoding, and the name of the switch was changed to Dolby FM decoder. Now, Dolby FM never took off as a broadcast standard, so it's an obsolete feature on both variations. So for all intents and purposes, the G-9000, 9000DB, 901, and 901DB are all the same. So moving forward, even though the video is about a G-901DB, you will hear me refer to it from here on as a G-9000, just to keep things simple. So it's pretty common knowledge that the DB features on the 8080DB, 9090DB, and QRX9001 are notorious for causing reliability issues. This is because those units have specific Dolby noise reduction built in for recording and playing back tapes, and the circuitry is integrated directly into the main signal path. So when those Dolby boards start to fail, it kind of interrupts the entire function of the receiver. That's not the case with the DB variants of the G9000. None of them have Dolby noise reduction tape features or those problematic boards. The DB simply refers to the ability to decode Dolby FM on board. So it's something that you don't need to worry about being a problem with the G9000. In order to understand where this receiver fits into the overall Sansui landscape, I thought it would be helpful to explore some of the other devices that were produced during the same time frame. If we look at some of the catalogs from 1978 through 1980, we can see the G transition take place. So looking at the 1978 catalog, the G series, when it came onto the scene, was just the small models. So we've got a G2000, 3000, and 5000 sitting on top of the outgoing XOXO models, the QRX9001, 9090DB, and 8080DB. So we scroll down, we can see those here. So these are our 3 beginning G models at 16, 26, and 45 watts, just the low power guys. And then the high power models were still not introduced yet, so they were still selling the 8080DB and 9090DB as the high power offering in that year. Looking at the 78-79 catalog, we can see the full deployment of the G series. So It starts out with the big boys, the G-22000 and 33000, and these are the real flagship, but it's kind of a different category because these are two-piece models. So it's more of a tuner preamp or separate style system and not really a receiver. This is the full 1000 series G units deployed. So we have the 2, 3, and 5000 that were coming out around 78, and now the 6000, 7000, 8000, and 9000 are all introduced here. This is an internal pic of the G-9000. We'll see some more of that a little bit later. And then look at this. They're still touting the 9090DB and the 8080DB. So we still have the XOXO models being transitioned out. So moving into 1980, this first page really tells us everything we need to know. So we've got a transition from analog metering to LED bar graphs and vacuum fluorescent digital displays in the tuners. So in my opinion, this is really the era where a lot of hi-fi companies went downhill pretty quickly. If we look at the top of the line receiver here, G-90700, this is what replaced the G-9000. Went up to 200 watts per channel. We have a VFD for the tuning instead of the analog tuning meters, and also the analog power meters are replaced with the bar graph, and the build quality in general is just not as good. Less main filter capacitance. It went down to 2 capacitors rather than 4 for the power supply, so a really big reduction in build quality and expense coming up in 1980. If we come down here, we can see the rest of the GX700 series deployed and the GX500 series, which were kind of a slightly modified 1000 series. So if you see a G5500, that's like a G5000, but it's going to have slightly different aesthetics and a little bit more output power. So the 1000 series came first. It was slowly replaced by the X5500, the X500 series for certain models. Then the X700 series came into full deployment in 1980. Even though the G-9000 is not technically the biggest, most powerful receiver that Sansui made, it seems to hold the same respect as the SX1250 does for Pioneer collectors. A detailed look at both models helps reveal some of the motivations and marketing trends that were going on during this era. The G-9000 and SX1250 are both rated at 160 watts per channel with similar specifications and features, produced at the sweet spot in the power wars where there's proper balance between output power and build quality. As the power war started to ramp up, the power levels became a bit outrageous, resulting in the Pioneer SX1980 at 270 watts per channel and the Sansui G33000 at 300 watts per channel. Both are beautifully built units, but even today they're more of a statement piece for collectors rather than a practical device for everyday use. Both the SX1250 and G9000 were eventually replaced by higher powered top-of-the-line models from the next series, which are universally considered to be a step backwards in build quality. The SX1280, for example, is less service-friendly than the 1250, and cost-cutting is evident in the reduction of the size of the main filter capacitor bank and internal shielding. The same goes for the G9700, which replaced the G9000. The 9700 is technically the most powerful single-chassis receiver that Sansui ever produced, but again, cost-cutting is evident in the reduction of the power supply capacity and overall build quality. Don't get me wrong, the SX1280 and G9700 are both very good receivers. They simply mark the beginning of the end of the golden age of high-powered solid-state receivers before the inevitable decline into the dark ages of the 1980s. And it's for that reason that I believe the G9000 has staying power and continues to fetch higher resale prices than its more powerful bigger brother, the G9700. All right, let's take a look at some of the interesting literature that came in with this unit. I was pretty excited to get my hands on a G-901DB because it's such a rare variation of the G-9000, but perhaps even more rare is this collection of original literature that I received when I got the unit. This is the type of thing that we don't get to see every day, so I thought it would be kind of interesting to go through each one of these documents in detail. Let's start out by taking a look at this little operating instructions or owner's manual booklet. So first off, I don't get to see this stuff very often because if a customer brings in a unit for service or restoration and they have the literature, it usually doesn't come to me. Once in a while, I'll get a fold-out schematic from a customer, but owner's manuals, promotional literature, I just don't get to see it. And the units that I buy for myself, I'm usually targeting units that are in pretty poor condition and the service literature is long gone. So for me to see some of this stuff in person is pretty fun. And something that goes along with that, when I'm looking at manuals, they're almost always in PDF format. And when you're scrolling through it, you just don't think of certain things. Like I always thought this was an 8.5 by 11 document. And then when I saw it in person, it's like, no, this is like a half-page booklet. So it's just something that didn't translate during scrolling. Another thing is the inside has color accents, which the scan is in black and white. So I never knew that. This manual itself has to be extremely rare because it's actually labeled G-901DB. On the service manual that's readily available for the G-9000, it says G-9000/901. So I had assumed that a lot of the literature, they just made one printing for both versions, but in this case, this is specifically for the G-901DB, that when the faceplate is represented anywhere, it's this darker color. And if you look closely in the glass, you'll actually see the G-901DB logo. So this has got to be a super rare piece of literature. So starting out looking in here, I just love this first page with this diagram. It shows this receiver is very unhappy. He's sitting on top of a radiator with the sun beating down, and he's sweating profusely. And then this one's also not happy because he's getting wet, because this little fish that's accented in red has splashed water onto the unit. So just a really fun drawing that somebody put together. I'm sure whoever made that had a lot of fun. The rest of this document just goes over all of the input and output connections, how to connect antennas, tape decks, processors, the whole works. And we'll be going over this in more detail later as we look at some of the more advanced features of the unit. So I'll put this one away for now. We'll get a closer look at some of that later. Let's move on to the schematic. Just like the last document, this one is also called out specifically for the G901DB. And as a technician, I love this type of documentation because you can fold it out and get the entire schematic for the unit represented almost on one page. So we have the tuner section here. This other page shows the preamp and power amp sections, and then on the back we have the power supply. So as a technician, a lot of times when scrolling through a PDF document, there will be lines that go between sections and they'll be cut off by whoever scanned it, and not everybody takes the time to stitch everything together properly. So it's so much easier when you have everything displayed at once like this. So I really like to see these fold out documents. So they're kind of cool to look at by an owner, but as a technician, this is gold. This next document is a warranty information sheet, and it has the serial number of the exact unit that I own. So when I eventually sell this G901DB, this set of literature will go along with it. I don't like separating serial number matched stuff, so this will move on to whoever owns this piece after me. There's some little creases here. I think at one point it was either folded or it has the creases to be able to fold it in envelope size, and it's just been sitting there flat for years. But what this document outlines is all of the exemptions. So it's stuff like if you obviously smashed it or stuff like that, and things it doesn't cover. But it also says down here that the warranty won't be supported unless you have proof of purchase. So they give you this little pocket here. And the idea is that after you buy your unit, you would shove your receipt in here so that the receipt always stays with the warranty information. And it's a reminder to bring that receipt with you when you take it in for service. This is a document that shows all of the international service centers for Sansui. So if your unit broke down, you could look through this booklet and find whichever service center is closest to you and get your unit there for service. And one of the most interesting things I thought about this document is how many USA locations there are compared to the rest of the world. So everything in green here is United States. So we've got Alabama, Alaska, Idaho, New Hampshire, New Jersey. The whole United States is represented here, and it's over 3.5 pages of locations. So it would be interesting to know how many of these service centers are still in operation today. I can't see it being more than like 3 or 4%. The audio repair industry is just nothing like it used to be. So yeah, it'd be super interesting to know how many of these are still in business. Looking at the rest of the world, we have America, so this would have been North and South America, Canada. So we have Europe on this page. We've got Middle East, Southeast Asia, Africa. So Sansui was selling these pieces all over the world, and this is a good representation of that. The final document that we have here goes over all of the changes that need to get made when moving the receiver from one country to another where the mains voltage might not be the same. So it has a bunch of different diagrams that outline the process for changing things over on all of the different transformer versions. It also goes over FMD emphasis and fuse selection. We'll go over this in more detail a little bit later. But the interesting thing here is that in the schematic, there's 3 different versions of the power transformer. This one down here is marked EU BS, I believe that's Europe and British Standard, and we have 220 and 240 volt only on the primary. But on the switching side, they're switching both the hot and the neutral, which is interesting. So that must have been a requirement specific for that region. This is the model that we have. It's more of a general export model, so it gives us all of the power transformer primary options. We have 100, 120, 220, and 240 that are switched on a block. And then it looks like the power is only switched on the hot side of the circuit. This is one labeled UL CSA, and UL is the same as it is today, Underwriters Laboratories, and that's like the certification to make sure that all of the electronics meet the standards for the United States. CSA is Canada, and on this one, the power switch is also only on the hot side, but it's a double pole, so that must be for increased current capacity or something. So that's the various power transformers which are represented in these diagrams. And this would have been a super useful document to somebody that was in the Army or in the Navy and were stationed overseas. They bought a nice Sansui receiver at a PX and then were bringing it back after their deployment was finished. This document would help them get it converted back to use on US mains. Okay, let's take a close look at the front panel of this unit. So we'll start off with the power switch. When I flip this on, our dial lights come on and the protector light flashes. When the time delay has finished, we're going to hear the relay click and it'll switch over to green. So now the main protection relay is engaged, and then there's 2 additional relays, one for speaker A and one for speaker B. So when I manipulate these controls, I'm not actually directly controlling the signal through this switch. This switch just tells a relay in the back of the unit to turn on or off. So you can kind of hear that loud tinging sound when I activate that. And we'll see more about that when we open up the unit later. I've got a headphone jack here that's pretty self-explanatory, and then next up is the tone circuit. So in this unit, the tone control here, when it's in the down position, that's when these come into play. When it's up, it's defeated or bypassed. We have a choice between 400 and 200 hertz for the bass control. So if you wanted to just affect the very, very low sounds, you would go to 200 hertz, and then you could adjust that here. And then for the treble control, you have a choice between 1.5 kilohertz and 3 kilohertz for the treble roll-off there. So let's demonstrate that. I've got a little bit of pink noise coming in on the auxiliary input. So in the defeat position, I can rotate the controls and nothing happens. And this is a difference between this and the XOXO series, like a 9090DB. On those ones, the mid-range is always in circuit. You can't defeat it. But on this one, it defeats the entire tone circuit. So if we want to activate the tone, we push this switch down. And now when we manipulate these controls, it changes the sound of the signal. And then we set it a custom EQ. We can defeat it or bring it in there. This next control here is called audio muting. And what that does is it takes whatever signal is coming through the preamp and it takes it down by 20 dB. So the signal's still there, but much quieter. So what that's for is, in the manual at least, they outline it as, say you're listening to your stereo and you get a phone call and you just want to run up and quickly turn the unit down, but you want to return to your normal listening level fairly quickly afterwards. So instead of grabbing the volume control and then having to come back and spin that around, you just quickly flip this switch, take your phone call, and then when the phone call's done, you flip that back up and you're good to go. It can also be used if you have an extremely efficient speaker system and you're only operating in the first few detents on the volume control and you want a little bit of extra granularity. So you could activate the negative 20 dB and it would give you more range of use in the volume control before it gets too loud to listen to. So those are kind of the use cases for audio muting. Next up, the volume control itself is pretty cool. It has this little preset wheel inside of it that's a way to set a preset listening level. So if you know you always listen at a certain level, this allows you to quickly put it up to the spot that you want, and then say like you're listening to vinyl and you want to change the side, You could take your volume control all the way down to 0, change the side, drop the needle again, and then bring it back up right to the preset level that you were at. So that's kind of how that works. Next up, let's go over the loudness and the filters. So I'm going to bring the pink noise back in. When we activate loudness, it's going to boost some of the low and the high frequencies proportionally with the volume control. So as the volume control is rotated up, that loudness effect will taper off, and around 50% it's going to completely disappear. So that loudness is for listening at low volume levels to compensate for the way that the human ear works, to make it sound better or more flat to the human ear. Subsonic filter we're probably not going to hear. This is for very, very low frequency, but the high filter we'll definitely hear. And then we have the balance control to pan from left to right. I'm on a mono mic, so you won't really hear much of a difference there, but we are panning. And next up, we can go into the source selection and the tuner. I'm going to jump over all the way to this side here and start with the mic mixing level. If you plug a 1/4-inch microphone into here, you can mix a mic onto whatever audio you're listening to, so you could maybe sing along with the radio or something on vinyl. People don't use this a whole lot. In the manual, it tells you if you're not using the microphone, make sure that you spin the control all the way to 0, so that's where it will live most of the time. This control here is the tape monitor. So you see there's no tapes to select for sources on the source selector itself. If you want to listen to a tape deck, you would go to tape 1 here, or tape 2, and then the other selections on this switch allow you to copy information from one tape deck to another. The source selector here, as we spin this, it goes in between all of the available sources, and they're indicated on LED here. So we have aux, 2 phono inputs, FM auto, and AM. So what FM auto means is that if it sees a stereo beacon or a stereo pilot, it's going to activate stereo automatically. If the pilot's not there, you're going to be in mono. Now, if you are receiving stereo and for some reason you want to listen in mono, you can always toggle it here, and you'll see that FM stereo indicator LED will turn off. FM muting is for when we're going in between stations. So as we turn the dial on, when there's noise in between the stations, this will mute it out. And if for some reason you had a weak station that was below the muting threshold, you could deactivate the muting there so that you could properly tune into the station even if it was very, very low level. Along with low level stuff, we have this very interesting switch called FM Auto Noise Filter. And this is kind of like a variable FM blend. So when you have a station that's kind of weak and it's a little bit noisy, a blend control will take some of the high frequency and mix it down to mono to cancel a bunch of noise. So the way that this one works is it uses an optocoupler to variably change the high blend depending on the signal strength. So that's something you can activate if you're listening to a weak station that's kind of noisy and you just want it to quiet down a little bit. The FM IF band has 2 selections, wide and narrow. The way that they've designed this unit is kind of your default position where you want to be is all of the switches up. So you're normally going to be in the wide FM IF band. The time that you would use narrow is if you have a station that you're listening to that has another strong station very close to it and it's causing some interference. If you flip the IF band, and this is IF band width, if you switch it to narrow, it's going to have increased selectivity, so you'll be able to more accurately land on that exact station while rejecting the stations that are close to it, but you sacrifice a little bit of fidelity. So if the station is nice and strong and has no adjacent stations interfering, you want to be in the wide IF band to get the best fidelity. The last 2 controls here are Dolby FM decoder and 4-channel noise reduction adapter. On the non-DB units, this was previously called Dolby FM de-emphasis, and it got renamed Dolby FM decoder after onboard Dolby FM decoding was put onto the tuner board. So if we want to listen to Dolby FM, we would push it to on, but again, this feature is obsolete because there's no Dolby FM broadcast. So if you're listening to FM, all this would do is slightly change the sound. Normally you would just have that in the off position. Now for the 4-channel noise reduction adapter, this is basically just a processor loop, and I'll go into this in more detail when we go over the side panels. A lot of times with these vintage receivers, I'm tempted to convert the dial lighting to LED, but there was really no temptation at all on the G-9000. They did a very good job with the lighting on this unit so that all the meters and the dial are brightly lit, and it works well in all light levels. So right now we're filming with the shades all the way open, bright sunlight in the room. I'm going to lower the shades here, and you'll see kind of how the The lighting changes as the ambient level changes in the room. It's just a really, really nice looking, well-lit dial, and it makes the meters super visible and bright. So I really like how this unit looks with the incandescent lighting, and like I said, really don't have a temptation to change it. So while the shades are down and we're seeing this so brightly here, thought it'd be a good time to demonstrate the meters. So that's the last thing left on the front panel, is the large analog power meters, which are so cool. So that's one of the benefits of these big G series, is 4 analog needles to look at. All right, that does it for the front panel. Let's spin this thing around and take a look at the back. Usually when I spin a receiver around, we're going to talk about all the input connections, how to connect the speakers, where the antenna gets plugged in. That's not the case on the G-9000. All we have on the back panel here is the power cord, 2 unswitched outlets, and a single switched outlet. And this is because on the higher end G models, all of the connections are on the sides. So we'll talk about that next. But before we do that, I just wanted to mention some stuff about the heat sinks, which are pretty cool. So it's a 2-piece heat sink in the G-9000. 2 pieces for each channel, and you can kind of see a little seam here where the channels separate, and a bright kind of silvery color in there. That is the inner aluminum heatsink that's machined out or cast so that there's a pocket for each one of the output transistors to fit in. And then this secondary heatsink with fins, a layer of thermal compound gets applied, and then it gets stuck onto there and screwed in place. So a very cool design. The other thing that I like about the back of this unit is the feet. I always like to see this. It makes it so much easier to service. So when working on the power supply in this unit, it can be tipped on its back. The power supply can get folded down, and it's much easier to access. We're now looking at the left side of the unit. And before I go over the connections here, I just wanted to cover some general info about what we're seeing here on the side panel. So first off, this is an imitation rosewood wrap, and it's very similar to what you'd see on a G-22000 or 33000. And the reason it's like that is because it's the 901 variant. I think maybe because of the gunmetal faceplate being darker, they thought that the rosewood would kind of blend better with the darker colors. If this was a G-9000, this would be an imitation walnut wrap. Another thing that we can see here is this 220 volt sticker. So this thing definitely started out wired for 220 volt and was likely purchased in Europe somewhere and brought over to the States and then converted. Okay, let's talk about the connections. Here we have speaker A and speaker B. These are toggled on and off with the front panel AB switches. This amp is 4 ohm stable, so what that means practically is you can run a single set of 4 ohm speakers one at a time, or you can plug in 2 8 ohm sets of speakers and run them either individually or together. This section here is where we link the preamp and the power amp circuits together. On a conventional receiver, you might see a metal jumper bar that goes in between these to link them together, but here with the G-9000, it's done on a switch. So this has 3 positions: connected, separated 1, and separated 2. When it's connected, it's acting just like a physical jumper. When you're in position 1 or 2, the preamp section is switched on and off with the unit's main relay. There's a little read relay back here. I guess it gives a time delay in case you're turning this on when you have a power amplifier that's already on. So they have a little read relay and circuit. So if you're having trouble with this and you can't get a signal out of the preamp section when you're in one of the separated things, you might need to check that little read relay. On the amplifier section, positions 1 and 2 give you 2 options: direct coupled and capacitor coupled. And a use case for this would be, say you're going to plug a tube preamp into the G-9000 and use its amplifier section only. Sometimes a tube preamp will have a power on transient where you turn it on and there's a big DC spike. If that goes in direct coupled mode, it's going to go straight to the power amp and it's got a potential to damage your speakers. If you have it in the capacitor coupled mode, that DC that's coming from the preamp device is going to be blocked before it gets to the power amp section. So that's kind of how those connections work. I found this little section in the manual that outlines a use case for the pre-out main-in section that I hadn't thought of before. I don't know why, it's pretty simple and obvious, but I didn't think of it. So one of the ways that you can run this is from the preamp output, you feed that into an external 2-way crossover, and then from the crossover, you feed the low back into the power amp of the G-9000, use that to power the low frequency portion of your speaker, and then you take the high from the external crossover, feed that into a different power amplifier to run your tweeter. And it looks like they're representing almost like JBL drivers. So thinking of a 2-way JBL speaker or something like that. So that's an interesting application for the pre-out main-in section where you continue to use both the preamp and the power amp simultaneously. Another thing that you can do with that is run an external subwoofer. So in that case, you'd come from the preamp outputs and go into a Y splitter, you would feed one half of that Y out to the RCA inputs on your subwoofer, and then the other half would feed right back into the power amp. So those are just some general applications for the pre-out main-in section. So because the connections are on the side of the unit, Sansui supplied this little channel here, which allows you to kind of hide the cabling. So say we're plugging in with an external device, you can technically plug your cables in and then route the wiring down into the channel to go out the back of the amp. Now, unfortunately, what this means, because this stuff is sticking out, is that when you look at the unit from the front, you're going to see all your connectors. So it's not really ideal on this side of the amp, at least. So one of the things you can do to get around that is use something like a 90-degree adapter like this. And maybe there's some thinner than this. These are a little bit chunky, but this way you can get the connections to face the other way, and then get it so it's a little bit more sightly from the front. Okay, this is the right side of the unit. The first thing you'll notice is that the jacks are recessed back into the unit, and quite a ways actually. So unlike the other side, when we plug in an RCA cable, we have plenty of room to curve the wire around and dress it into the side channel. So you can see it curves in nicely, and then from the front we won't be seeing it protruding from the side. So it's nice that this bay is recessed here. And then for the connections, this is our antenna inputs here. So this is for 75 ohms. So you have a piece of coax running to an antenna in the attic or something. You can peel back the shield, put it underneath this, and put the center conductor into this pin for 75 ohms. And then a 300 ohm antenna can get connected here. For AM, this is just an extension. So there's a built-in antenna that's inside of the unit underneath the cover. A lot of vintage receivers have an AM loop stick antenna that's on a swing arm in the back, but in this model they have it inside. So we'll see that in a little bit more detail later. Down here we have two phono inputs, phono 1 and phono 2. That's the ground for the turntable. And these little plugs are actually called out in the manual. So if you're just using one turntable, you would connect it to phono 1 and then use these shorting plugs in phono 2 to short out this input. And that's just to keep excess noise out of the phono stage. We have an auxiliary input here and then two tape loops. This plug here is only for tape 2, and that's a one-wire DIN connection if your tape deck has that and you prefer to do it that way. All right, let's talk about this section, 4-channel / NR adapter. This section that's labeled 4CH / NR adapter, that stands for 4-channel or noise reduction adapter. And it's basically a processor loop, but in order to use it properly, you need to understand where it's located in the signal path. So if we look at a block diagram of the G-9000, we'll see that the 4-channel adapter is placed after all of the sources, but before the volume control, and that's important. When you use it with a noise reduction unit or a equalizer or something, it's going to operate just as you expect. When you push that 4-channel adapter button on the front panel, it's going to loop it through here and operate just as you would expect. But if you're going to use this with an external quadraphonic decoder, that's where it can get a little bit tricky. So they have it shown here with a device called a QSD1, Sansui QSD1. And the way that it's connected is out of the processor loop, you feed that into the surround or a 4-channel decoder. The front output from the decoder gets fed back into the loop. So the G-9000 would be amplifying the front channel, and then a separate amplifier would do the rear channel. The problem is when you change the volume on the G-9000, it's only going to adjust the amplitude of the front speakers. So it's almost like you'd need to set a preset level on the G-9000, and what if this amplifier had attenuators to set those as well, and then manage your volume in 4-channel mode with a concentric control on this device. So it's all a little bit cumbersome. So I don't really recommend using this as a front channel amplifier in 4-channel mode. It's just really confusing. If you want to do quadraphonic, I'd recommend getting like a Sansui 9001 or something like that and just go with something that's set up with 4 channels to begin with. Another thing that I wanted to touch on briefly is the differences between a G-8000 and a G-9000, just in case somebody's in the market for one of these receivers and is having a hard time making a decision whether or not to jump up to the flagship G-9000 model. So some of the basic things, the G-8000 has a watered down tuner with less features, so there's no IF bandwidth switch. It has a smaller board, the RF power supply is different, so just know tuner is slightly different in performance and features. The G-8000 does not have turnover switches for the tone control circuitry, but the rest of the board is the same, so they just kind of removed some of the features to save some money. There's no indicator lights on a G-8000, so for your speaker A and B, you have to rely on seeing whether your switch is up or down to know if your speakers are on. You don't have the actual extra visual indication. On the inside of the unit, when we look at this, we'll see these specialized oval-shaped capacitors in the G-9000. That is not present in the 8000, they're just regular conventional capacitors. Now, that's not a huge deal. It's actually easier to replace caps on an 8000 than it is on the 9000. We'll see some of the challenges I had to go through with those oval caps. So that's not necessarily a deal breaker, but the power supply is slightly smaller in overall filter capacity. They have slightly different phono stages, but they have the same driver board, same power supply, same filter circuit. So a lot of the base stuff is similar. They've just pulled some of the features out and reduced the output power and the power supply filter capacity just to lower the price of the unit. So if you're trying to decide between G8000 and 9000, they're pretty darn similar, but if you're a collector and you want to have that flagship model, the 9000 would be the one to get. It's always going to demand much higher value, and you'll have all the extra features that you never knew you needed. Okay, let's move on to taking a look at the restoration that was completed on this unit. This is what the G9000 looks like with the top cover removed. Let's take a quick tour around. We've got giant toroidal power transformer, 2 vertical cards on either side of the transformer that house some of the power supply components. We've got rectifier diodes for the main filter banks, soft start resistor fuses, stuff like that. This is the dynamic oval capacitor. So it's really just 2 capacitors in one can. It's more of a marketing thing. But we have a individual capacitor bank for each channel. The driver cards are housed here and here. I have one removed because I'll be showing it in detail in a little bit. Tuner board, tuner front end, AM antenna. This is the add-on board for the DB model, so that's where it does the Dolby decoding. We've got heat sinks down here for the output transistors, and these little points here are where we measure and check the bias. Meters are located underneath here, just 1 lamp each, and then for the dial there's a lamp down here and a lamp down here for lighting that up. It does a really good job. All right, let's jump into the actual restoration that was involved in this unit. So starting with the tuner board, this is not really a super necessary rebuild. If your tuner's fundamentally working, sometimes it's better to just leave it alone. But in my case, I decided to do a full recap on this. And just for reference, these are the parts that I found that were suspect, either on their way out or replaced because of known issues that they can create. So there's a lot of these VD1212 diodes. This tantalum capacitor was on its way out. And a lot of these other caps were just creeping up in ESR. It's mostly stuff that's like 1 microfarad and lower. All the caps here were fine. And it was surprising these tantalums were also very good. So it kind of, on tantalums, it kind of just depends. The ones in Pioneer are almost always bad, but in other manufacturers, they use some other variants, and some of them hold up just fine. But these were all the parts that were good. They could have stayed in the unit and not caused any problems for a while. I also recapped the Dolby FM board, the vertical Dolby FM board, which in hindsight, I could have probably just left this alone. This is a useless feature, but since I was replacing every other cap in the unit, I figured I'd get it done. Dealing with these dynamic oval capacitors is probably the most challenging part of a G9000 restoration. In my case, I did leakage testing on all 4 of these, and 1 of 4 was bad. So I opted to replace all of them, and what that involved was restuffing the caps by prying them open, pulling out all the guts, restuffing them with brand new parts, and then sealing everything back up. And it turned out really well, but it was very time consuming, and I don't know what toxic chemicals I was handling or breathing, so I really don't look forward to doing that again, because rebuilding these is for the birds. Okay, here's one of the rebuilt driver boards. So neither channel worked when I got this unit. It was stuck in protection, and the main contributor to that was bad fusible resistors, so those got replaced. I did do a full recap on this board. Reason being, the parts are exposed to a lot of heat. So these caps are both 33 microfarad, 25 volt. This one tested fine, but the other one that has this shrunken top didn't fare too well. This is down to about 20 microfarads and it's creeping up in ESR. So the heat exposure did do a number on these caps. So those were replaced. These ones I think could have stayed 0.022, but I replaced it with a film cap because it was in the signal path. Trimmer resistors I always like to replace, just because, especially the bias ones, if there's a dead spot or something in there, it can cause a spike when you're trying to adjust the bias and potentially blow up the amp channel. And then these Zener diodes were just preventative. So a lot of stuff, it was really just the fusible resistors, I think, holding this thing back. But while I was in there, I freshened up the thermal compound and the transistors, checked everything out, and replaced everything that I normally do. So that's the driver boards there. And really that's about it on the top. I replaced some parts in these vertical power supply boards, but it's just a couple caps here and there. So not much more to talk about restoration-wise from the top. The majority of the work on this unit is done on the underside. While the top cover's off, I thought it would be a good idea to go over the conversion process for coming from somewhere in Europe, for example, into the United States. And what this document shows is all the various versions of the power transformer and the primary wiring. The one that we have has the convenient multi-voltage switch, but some of the other ones only offer a couple different voltages, and you have to move plugs and stuff around, so that's all shown here. But for us, we have the nice easy way. We also need to check the FM de-emphasis and the fuse. So the thing to know on FM de-emphasis is that in Japan and Europe, it's 50 microseconds, and in the United States and Southeast Asia, it's 75 microseconds, so we need to set it to 75. This is the multi-voltage selection switch, and this is currently set in the 120 volt position for US mains. Originally this would have had the arrow pointing towards 220 according to the sticker on the outside of the unit. And then I also pulled and checked the fuse. There's some little text down here that says 12 amp fuse at 100 120 and 6 amp fuse for 220 240. And the reason is, when you set these up, there's different combinations of series and parallel on the power transformer primaries, and that dictates the current and what fuse value needs to be in there. So that's where you would change the voltage. Next up, let's look at the FM de-emphasis. The FM de-emphasis switch is right here on the edge of the tuner board. Let's zoom in. And it's on the board. It says 75 microseconds is towards the outside, and this would be the 50 microsecond position. So since we're in the US, we're going to be at 75 microseconds, and that's the adjustment. This is what the G-9000 looks like with the bottom cover removed. We've got power supply in the middle. This is where the vertical power supply cards connect. Little Molex connectors, similar to how the SX1250 works. These are the filter banks with the dynamic oval capacitors. RF power supply, phono stage, and then the whole preamp section is all on the front up here. Like many other vintage receivers, I spend a lot of time on the power supply. It's a very important circuit, and there's a lot of parts that can get stressed out. So the power supply and protection circuit here got a full recap. I replaced a bunch of known troublemaker transistors, and anything that was mounted on heat sinks got fresh thermal compound. All of the relays have been replaced. We have a total of 4 relays here: soft start, the main protection relay, and the speaker A and B relays. Let's take a look at some of the parts that were pulled out of this board. Let's start off by taking a look at the relays. This is the soft start relay. We could see quite a bit of pitting on this one, so that was a good one to replace. The main protection relay is in really good shape, actually. The contacts were pretty fresh on there, but replaced it anyway for good measure. And then on the speaker relays, I kind of expected this. One of them is in fairly good shape, and the other one is pretty trashed. So this one here, the contacts are quite nice. Like this one would probably polish up and work fine, but this was likely the speaker B relay, and the speaker A relay is not super trashed, but it is kind of pitted, especially on the main contacts. So that's these here. They look kind of okay, but on this side, these contacts are pretty pitted, and the plating is almost gone. So I like to put fresh relays in here because the signal goes directly through here, and it can contribute to distortion and intermittency if any of these are going bad. Here are the rest of the parts in the power supply that I replaced. You can see that some of the transistors here, Zener diodes, VD1212 diodes, and we can see some of the heat stress on these capacitors due to discoloration. We've got shrink-in tops there, and I forgot to mention I did remove a bunch of corrosive glue as well from the board when these original parts were removed. The preamp section in the G-9000 is a little bit difficult to work on. There's Molex connectors for most of the connections, but there are some that are still soldered in place, so I kind of had to disassemble the whole front of the unit in order to service it. Another challenge here was these switches get very dirty, the source selector and the tape monitor switches, so I completely desoldered those from the board and take out the wafers individually, clean them, reassemble them, and put them back together. While I was in there, I did all the caps and also the known troublemaker transistors. RF power supply got new caps. Phono stage, I did a bunch of audio grade parts in there because it's a highly sensitive circuit. Replaced some lamps, did the tuner alignment, you know, the normal stuff. But on the G-9000, I would say is probably the most important things are making sure that the power supply and protection circuit's in a good place, the relays are nice and clean, and the fusible resistors and stuff in the driver board have been addressed. So on one of these, if it came into my shop, I think I could probably get away with a light servicing if someone local just wanted one back up and running. But the full restoration on one of these is a pretty extensive job. Let's see how this unit performs at the bench. I'm going to start out by verifying just the power amplifier alone. So the way I have this set up, the pre-out maintenance switch is on number 2, so the preamp and power amp are separated from one another, and it's in capacitor couple mode. I just wanted a little bit of extra safety margin there with the capacitor coupling. Then I'm feeding a low distortion signal in from my Panasonic analyzer directly into the power amp. Speaker B is connected to an 8 ohm dummy load, and across speaker A we're monitoring for distortion on the Panasonic. I'm going to be verifying the G-9000 specifications off of the brochure rather than the service manual. The brochure has tighter tolerances and it gives me a lot more granular information, so that's why we're going to be working out of the brochure. The first thing that I want to verify is the total harmonic distortion. So this plot here on the x-axis is showing us output power. So we're going from very low up to rated power, which is 160 watts, and they're saying that's where the distortion is going to rise. And they're giving us 3 test frequencies, 20 hertz, 1 kilohertz, and 20 kilohertz. The 20 kilohertz is this one up here. We normally see on power amplifiers that the higher the frequency, the higher the distortion. But just looking at this graph, 0.01% is here. So their 0.02% spec is all the way up at this line. So we should be seeing extremely low distortion values here. And it looks like the 100 watt mark is where it should be the lowest. So I'm going to start there. We'll start at 100 watts at 1 kilohertz and see if we can verify this. So let me turn on the oscillator. And you'll see here we're making 100 watts on the left channel and 95 watts on the left channel. It looks like a big discrepancy here, but it's near nothing. If you look at my traces here on the oscilloscope, they're basically overlapping. There's not very much of a discrepancy between left and right channel here. So even though that looks like, oh, 5 watts, this is fractions of a dB, so that's nothing to worry about. But look at this distortion level, 0.0014, 0.0015. So that's even less than what they're saying here. At 100 watts, we're below the graph. So that is crazy, crazy good THD performance. Let's take this to a couple different frequencies and see what happens. So I'm going to put this up to 20 kilohertz. And we're at 0.009%. So this graph is showing me probably around 0.006. We're closer to this mark right up here. So it's not performing up to the spec sheet at 20 kilohertz, but this could be related to my cabling in the test rig. We're measuring extremely, extremely low distortion levels. Let's try at 20 hertz. It's going to take a while for this to all settle down. Looks like 0.002%. So at 20 hertz, it's probably this line that's creeping up a little bit. Realistically, we're showing right in this area. So at 1 kilohertz, we are pretty close to specification, if not even better. Let's work with the 1 kilohertz level and just kind of sweep the power range and see if we can duplicate this curve. So let's go back to 1 kilohertz for the test frequency. And let's ramp it up first. So I'm going to take the amplitude and I'm just going to ramp up my test signal to go to rated power of 160 watts. And it's staying pretty stable up until this point. Now it's starting to rise a little bit. We're at rated power right there, and we're at 0.004%, which is right around there. So we're going to have this exponential rise now. We should see it start increasing. Yeah, we're already at 0.03%. And you can see we're still pretty clean here on the sine waves, even at 180 watts. So let's back this back down and go the other direction. So what we should see is that as we decrease output power, distortion will slightly rise. I'm at about 40 watts here, 0.002% approximately, and this should continue to rise as we reduce the power. Yep, starting to come up. And then let's get down to, what are they saying, 0.2 watts. So we'll go really low. Let's see. Okay, so we're looking at this line here, and they're saying 0.01%, and we're right about there. So this curve tracks extremely well for 1 kilohertz. I don't know if my test equipment is capable of getting the proper results at 20 hertz and 20 kilohertz. I'm going to skip those measurements, but the takeaway here is we're tracking the 1 kilohertz curve almost exactly, and it's performing really, really well. So this is an extremely low distortion power amplifier. For this next test, all of the connections are the same, but I've unplugged the signal from the power amp and plugged it into the auxiliary input on the right side of the unit, and then I've switched the coupling switch to connected. So right now we're running through the preamp. I've got the volume control at about 50%, and we're fed into the auxiliary input. So what we're looking for here is no more than 0.02% THD, I guess, for any frequency at rated power. So let's take this up to 160 watts. And for some reason our channel balance has improved when we were connected through the preamp. So I don't know if that's just luck that the preamp has a slight imbalance in the other direction, but we'll take it. I'm creeping up on 160 watts there. And we're, yeah, well below 0.02% for 1 kilohertz. Let's take this frequency and let's kind of just go up in increments. So I'm gonna go 5 kilohertz, still good. Let's go to 10K. We're losing a little bit of amplitude, so I'm gonna raise this up. Still below 0.02%. Let's go to 20 kilohertz. And this is where it can struggle a little bit. But we're still right in there. So that's good. Let's take it down in frequency. Let's go to 400 hertz or so to start. Amplitude back to 160. And based on the distortion curves, we should have no problem. The challenge was going to be that 20 kilohertz. Let's go to 20 hertz from here. And yeah, well below that. So we've met this specification of 0.02% at rated power, 20 hertz to 20 kilohertz. So I'm happy with that. This next graph is kind of interesting. What they're doing is feeding a 1 kilohertz test signal into the auxiliary input, putting out 250 milliwatts at the speaker output, or 0.25 watts, and then looking at the individual harmonics with relation to the fundamental. So this peak here is the 1 kilohertz test signal, and they're just showing here that any individual harmonic is nowhere near 0.01%. So we can look at that on the Panasonic with this alternate mode. So the way we were measuring before was THD plus N, which is shown here. So at this specific frequency and output power level, we're at about 0.06% through the auxiliary input. If we shift this into the THD mode, this rejects the noise component and it shows me the individual harmonics. So this big line at the top is the total of these added together, so the THD, and then each individual harmonic is shown here. And this kind of mirrors what this graph is showing. I've got 0.01% here, and all of our harmonics are way, way down here. So that, I would assume, verified as well based on this test. Next up, I'm going to be verifying a spec known as max clipping power, which is basically just looking at how much power the amp makes before it actually starts clipping. Because we're doing all the distortion testing at like 160 watts maximum, but the amplifier can technically create more power than that. I don't put a lot of value on this specification because me personally, I'm never going to be pushing an amplifier that hard, but a lot of my customers want to know this specification, so I always do this test and put it on my reports. I'm going to be using the Siglent oscillator for this because I'm not concerned about the actual distortion level. I just want to see where it clips, and it's easier for me to creep up on the value with this signal gen. So right now I'm putting out 160 watts into both channels. We're looking at the left and right channel on the blue and the yellow traces here, and then their respective total harmonic distortion residual is shown on the violet and the green traces here. So as I ramp this up, once it starts to clip, we're going to see those violet and green lines change. So let's start taking this up. So there it is right there. That little point is actually showing the clipping happening. And if I go further, we'll see at the other side of the waveform, it's going to start to clip as well. If we keep taking this up, you'll eventually see the waveform start to flatten out at the top and the bottom, but you can see the distortion starts way before then. So I'm going to go right to the point where the distortion starts to be visible on that line. It's right about there. So that's my max clipping power, 180 watts, both channels driven. Let's take a look at the frequency response characteristics of this unit. So most audio devices are specified from 20 hertz to 20 kilohertz, or the human range of hearing. But they're giving us a spec here of 5 hertz to 50 kilohertz, and then saying the power amplifier goes all the way out to 200 kilohertz. So this is going to be interesting to verify and see how this actually performs. So what I'm doing here right now is looking at a 1 kilohertz sine wave fed into the auxiliary input, producing 1 watt. So that is the reference level there. I can set this as my dB reference. So right now, that's my 0 dB mark, and we're going to sweep the frequency up and down and see if we stay within the range that they've specified. So let's go in the downward direction first. I'm going to lower this 100 kilohertz or 100 hertz at a time. You can see my frequency displayed up here. And as we come down, you can see that it rises slightly above the reference level. We're at 0.04 dB. In the rise direction, they say it's not going to exceed 0.2. So let's keep going down. All right, 50 hertz there. We're up about 0.14 dB, but still not exceeding that specification. That's 20 hertz, so that's the human range of hearing. We're right down to 0 dB again. So there's a little bit of a rise in low frequency, but not bad. And then it's going to start to decrease slightly as we come down. I'm going to stop at 10 hertz because it's going to start to, yeah, you can see there it's already having trouble reproducing the waveform. But minus 0.2, that's well within the negative specification there. Let's take it back up to 1 kilohertz and go the other direction. So I'll do this 1 kilohertz at a time. And we can see that the waveform is shrinking. Here we will slowly see this start to come down. We're at negative, let's see where we go to negative 1 dB. Negative 1 dB is right around 23 kilohertz, so just outside the human range of hearing. And we're still within spec, but I don't think this is going to make it all the way up because this is starting to come down pretty quickly. At about 35 kilohertz, we're around that specification, so we're not making it quite to 50,000 hertz, but let's just see, just for reference, where that ends up. So there's our 50 kilohertz, we're negative 2.32 dB down, and you can see that our amplitude of the waveform has shrunk there. So the frequency response isn't exactly what they're saying in the specification sheet, but to be honest, I'm not concerned too much. When you go above the human range of hearing, it's more of just to make sure that the very high harmonics and things are being properly maintained. I'm more interested in if this power amplifier by itself actually does 200 kilohertz, so let's check that next. Okay, I've now rearranged the connections, so I'm feeding the signal generator straight into the power amp, and we can see that slight deviation that we had before is present. And let's switch this to here, and let's reset our dB reference. Okay, so this is again at 1 kilohertz, and I'm not sure if this is the correct way to do it. Maybe I should be at 100 kilohertz as my reference, but we're gonna go with this and see what happens. So let me take the frequency down first like we did for the preamplifier. That's 100 hertz. Continue going down. .30 hertz, it's starting to get in that negative range. They're saying negative 3 dB, so let's keep going. Take it down to 10 hertz again. There's 10 hertz, less than 1 dB. All right, back up to 1 kilohertz, and let's see how far this thing goes into the stratosphere. Let's take it up to 20K to start. Remember, I think it was around 23K. We were at negative 1 dB with the preamp in circuit. Let's keep going. Let's go to that 50K mark. Negative 0.7. Let's go to 100 kilohertz. negative 1.5. And let's see where it gets to negative 3 dB. Yeah, they aren't lying. Negative 3 dB at 205 kilohertz. So that's pretty impressive. Now, another thing that's in the manual that I thought was very cool, or not in the manual, in the brochure, if we go up here a little bit, they're showing the square wave response of the power amplifier, which is pretty interesting. So where is it? Here we go. So they're showing a conventional power amplifier trying to produce a 5 kilohertz square wave, and then they're showing what the G-9000 can do with the square wave. So let's start without the 1 kilohertz square wave for reference. So that's producing a pretty darn flat square wave at 1 kilohertz. Let's take this to 5 kilohertz. I'm not sure that's quite as flat as what they're saying there, but that could be something to do with my load. But anyways, that's a pretty darn clean 5 kilohertz square wave. So that's, I guess, the frequency response characteristic of the preamp and the power amp. The last thing that I want to cover while we've got the unit on the bench is looking at the frequency response of the phono stage. And this is something that's becoming more and more important as vinyl continues its massive resurgence in popularity. So what we're showing here on the scope, I have a violet trace showing the 1 kilohertz square wave that I'm generating from the signal generator. I then feed that into something called an inverse RIAA filter, which produces this green waveform. And what this green waveform represents is what would happen if I tried to play back a square wave from a vinyl record. So this is my way of simulating this at the bench, so I don't need to set up a test record or anything. So once we feed this green waveform into the phono input on the G-9000, we should get a waveform that looks close to this violet one coming out. So I'm going to turn off the input signal, and we're going to see what the output looks like. So we're getting a really, really nice looking square wave out of this. There's just a little bit of a tilt to it, but overall this is doing a very, very good job of reproducing the proper frequency response. So this phono stage is looking good. We've come to the end of the Sansui G-901DB video. Thank you so much for stopping by the channel and checking out this content. If you like what you saw and you'd like to see some more, feel free to subscribe and come back. The project queue is near endless, so there'll be plenty more to come. Thanks again for stopping by the channel. See you next time.